Question 1. Determine whether each of the following function has an inverse function. Alright. Okay. So first of all, let's look at the 4 types of relation. Okay. First we have one-to-one. This means each object only has one image. So for this one, the function will exist. The inverse function also will exist because function is going this way. So we see each object has one image. Each object, one image. But inverse function will go this way. This is f inverse. So for this function, this one becomes the object. So here also each object has one image. Each object has one image. So perfect lah. One-to-one function, the function also will exist. Inverse function also will exist. So I write in purple. Okay. Next, if you have one to many, like this. So now here this one object has two images. So this is not a function. So the function f does not exist. Okay, because each object has more than one image. Cannot lah. One object must only have one image. Okay, but for the inverse function, going this way, this one will exist because one object, because now this one is the object already. So one object only has one image. This object also only has one image. So the inverse function will exist. Okay. Then we have many to one. Okay, here the function will exist because one object only has one image. This object only has one image. No problem. So this one, many to one, the function exists. But the inverse function, this is the object. So one object has more than one image. So this one cannot. Inverse function will not exist. Okay. And then lastly, you have many to many. So this one, we have one object, two images. Cannot. And then the inverse function, if this is the object, one object has two images. Cannot. So for this one, function also won't exist. Many to many. And the inverse also won't exist. Okay. So how to simplify this? You can remember, if the back has 1, that means the function will exist because it only leads to one image. If the front has 1, that means the inverse function will exist because it's leading to one image. Because inverse function is opposite already lah. Okay. So the back has 1 means function will exist. Function will exist. Front has 1 means inverse function will exist. Okay. Now let's see whether each of these has an inverse function or not. Okay, the first one here, I use blue color. Okay, the first one is one-to-one function. So the inverse function exists. This one is many to one. So many to one function, the inverse function will not exist. Okay, because in front not 1. Okay, you must just check the front is 1 or not. Okay, this one, let's see, each x only has one y, but each y has more than one x. So each x only has one y, but each y got more than one x. So this one we can say this is many to one. Many to one function is, will not have an inverse function. Okay, D. Okay, I erase this all first. Right, let's look at D. D, we can try to sketch a bit. Okay, we can draw our diagram. So 1, 4, 5 and 9. 1 becomes 2, 4 becomes 5, 5 becomes 8, 9 becomes 9. This is just 1 to 1 lah. So inverse function will exist. Okay, and then E. Again, same thing. -3, -1, 2, 5 and 9. Okay, these are all the objects. And then all the Y will be the images. So 2, 1, 4 and 5. Okay, 4 repeats, so no need to write twice. So 3 leads to 2, 1 leads to -1 leads to 1, 2 leads to 4, 5 also leads to 4, 9 leads to 5. Okay, so this is many to one. Many leading to one image. So many to one, the front is not 1. Remember, if inverse function, in front must be 1, then only it exists. So this one, inverse function, will not exist. Okay. And we look at F. Fx is 4 minus x squared. Okay, then we look at F. So Fx is 4 minus x squared. What we can do is, we can try to sketch this on a graphing calculator. So y equals to 4 minus x squared. Okay, so this will show us what the graph looks like. 4 minus x squared is an inverse quadratic graph. Okay, so it's upside down, it's a sad face. Then you plus 4 lah. Okay, so let's just try to sketch this. I use a different color lah. Okay, so this is our graph. So now we can find if it has an inverse or not. Okay, so another way to find if it has an inverse or not, using graphs, for graphs, you can use the horizontal line test. Horizontal line test. Okay, so what we do is, we try to draw a horizontal line and check how many places it cuts. Okay, if it cuts at more than one place, that means it's not a function. So here the horizontal line obviously cuts more than one place. Okay, it cuts at 2 places here. Here also it cuts at 2 places. So if it cuts at more than one place, it is not a function. It doesn't have an inverse function. So here inverse function will not exist because it has failed the horizontal line test. Okay, then let's look at G, last one. Fx is 1 over x minus 2 square. So you can say y equals to 1 over x minus 2 square. 1 over x minus 2 in bracket, this whole thing square. Okay, and then they specified that it's more than 2. So 2 is here. So more than 2 means the graph, okay, it doesn't intersect 2 lah. Okay, so the graph is like an inverse graph. The graph is like that. Okay, so here we try to draw the horizontal line test again. So your horizontal line only cuts at 1 point. Okay, so it only cuts at 1 point means it has passed the horizontal line test, therefore it has an inverse function. So the inverse function exists, okay, because it has passed the horizontal line test. Okay. So horizontal line test is best used for graphs, so you can see how many places it cuts the graph. If it cuts at only one point, that means the inverse function exists. That's it.